Hi everyone, this is your video on triangle congruence proofs. So in this video, I'm going to kind of talk you through the process of how we typically write these proofs, and I'm going to do a couple examples for you. Then there's one more video after this that has some more proofs, a couple more example type problems in there for you, okay? All right, so if you recall, in the last video, in the last set of videos on triangle congruence criteria, especially in the practice ones, that we did a couple of problems where we marked diagrams and then we used those to figure out which triangle congruence criteria we were looking at, right? Whether it was SSS, SAS, ASA, AAS, or HL, okay? Right? So when you are doing triangle congruence proofs, you're basically just doing that, right? Except we're writing it out in a very logical step-by-step manner and making sure that we justify all of our steps, okay? So we're essentially taking what is given to us in the problem and other properties that we know based on the diagram, or other properties that we know based on like definitions and things that we know about geometry. And we take them and we put them in a logical order to figure out if the triangles are congruent, okay? When you do triangle congruence proofs, essentially what you're doing is you're trying to find the right parts to show that the triangles are congruent, right? So we're trying to find three sides, like three sets of corresponding sides, or two sets of sides and an angle in between them for SAS, or a hypotenuse and a leg for right triangles, okay? So when you do these problems, you basically are going to follow four different steps, okay? So step one is mark the diagram and make yourself a roadmap, okay? Meaning ask yourself, okay, I have this information, what's missing? Like what missing parts do I still need in order to have an SSS congruence or an ASA congruence, okay? Step two is writing the actual proof. Okay, so we have to write out what is given to us. It's always your first line or your first couple of lines. Step three is to fill in the missing information, right? And usually that's proving that a missing set of sides or maybe a missing set of angles is congruent. Okay, and then your very last step is always the last line of your proof, which is write what you're trying to prove. Okay, so that's your proof statement. It's always the last line. Okay, and these steps are written out for you in your notes here on the right-hand side. Okay, now you'll see this diagram also in the notes that I gave you. Okay, but these are the most common extra things that show up in triangle congruence proofs. Okay, so these would be like extra things that they would tell you or that would show up in the diagram that can help you mark a set of angles as congruent or a set of sides as congruent, for example. Okay, but the most common ones are the reflexive property. Okay, when you have an angle or a side in common, so like this one that's marked in red. So I would say that that side is congruent to itself, right? I'm pretty sure that's side HJ. So I would say in a proof, for example, HJ is congruent to HJ. Okay. This is another very common one, vertical angles. That's going to give you a set of congruent angles here in the middle. So I would say, for example, angle BCA here is congruent to angle ECD. So that would give me a set of congruent angles. Okay. Dealing with our parallel lines, we often will get alternate interior angles. If you remember those, remember from our, when we would draw parallel lines cut by a transversal, then you'd have the alternate interior angles. Okay, so that's a really common one, right? So that's going to give you a set of angles that are congruent. And then we often have these either a midpoint or a bisector. So a midpoint, a segment bisector, or an angle bisector, which will give you congruent sides and congruent angles, right? So midpoint and segment bisector are the same they're going to give you the same result. They're going to give you two sides that are congruent. So in this one down here, for example, this would be like side TQ is congruent to side RQ. Okay, because I'm using the definition of a bisector. I know that a bisector creates two congruent parts. Same thing for the midpoint up here. A midpoint creates two congruent parts. So I would say, for example, KJ, side KJ is congruent to side, I'm pretty sure that's an I there, side IJ. Okay, right? And then angle bisector is a similar idea, right? If I'm told that this is an angle bisector, then that means you have two congruent parts. You have two congruent angles, two congruent parts. Okay, so for example, in this picture, I know these letters are hard to see, but I would write that this angle, I'm pretty sure that's BDH, is congruent to angle, this angle here, FDH. Okay, and then there's one special one, which is definition of a perpendicular bisector. So that's going to give you your bisect part, the two sides that are congruent, but it will also give you two congruent angles because the right angles are always congruent, right? Which is what this guy says here. So if you have two right angles, you can say that those are always going to be congruent, okay? One last thing I want to make sure that I tell you before I go and do some actual proofs for you, which is where I think you can see a lot of the process a lot easier when you see a couple of proofs just written out, is this note that I put for you right here. Do not assume anything if it's not given, meaning given in the diagram or given in the actual like phrases that they tell you, right? So just because two sides look congruent does not mean that they are congruent. You have to be able to justify every single thing that you say is congruent, okay? All right, so give me a moment to kind of erase my screen, clear this stuff off, and then we're gonna do a couple of examples together. All right, y'all, so here is our first sample proof, okay? So I made this side a little bit bigger just so it was easier for me to do my drawing and my writing because I have a text tool over here. Okay, so we're going to go through and we're going to follow the steps that we normally would follow. So I told you that step one, whenever you are doing a proof, is to take the information that they gave you and mark the information that you know on the diagram and kind of make yourself a roadmap. Okay, so here I have JX is congruent to KX, so I'm going to mark that with a little congruence mark right there. Okay, and then they told me LX is perpendicular to JK. Okay, so I know that this line here and this line here are perpendicular. So what that means, okay, the next step from that is that you have these two right angles right here. Okay, so just from my diagram right here, it looks like I have a side, right? I have one side right here. I have an angle. So wouldn't it be nice if we had one more side? And in fact, we do have one more side, okay, because LX is congruent to itself. Okay, so that would be my other side. Okay, so with that, I have side angle side, right? And I can show that those two triangles are congruent. Okay, so just by doing this little roadmap, I kind of have an idea of where my proof is going to go. Okay, so let's go ahead and fill in the actual proof. Okay, so the first statement is JX is congruent to KX, and I know that that's true because it was given to me. Same reason here, right? LX is perpendicular to JK. That was given to me. Now, when I did this on my diagram, I said to myself, okay, from this information, I am able to say that I have two right angles. Okay. So that's what I said next, right? So we said angle JXL and angle KXL are right angles. Okay, we can't just jump and say that they're congruent. We first have to establish that they are right angles. Okay, and the reason for that is the definition of perpendicular. Okay, so we're using the information from the previous step to justify our next step here. Okay, then right after that, if I know that they are right angles, then I can say that they're congruent. So angle JXL is congruent to angle KXL. Okay, and my reason is because all right angles are congruent. Okay, that's like a rule that I know. Okay, so what I have right now is I have an angle that I have justified right here. I have a congruence statement for an angle. I have a congruence statement for a side right here. And so I need my last congruence statement for my last side, which is that LX, side LX, is congruent to itself. Side LX. Okay, and remember, whenever you say that something is congruent to itself, that is the reflexive property. That one is used pretty often. Okay, all right, so now I have all the information I need, right? Now I can say triangle JXL is congruent to triangle KXL. Okay, and my reason is my triangle congruence criteria, which is this, SAS. Okay? All right. So again, we went through and we made ourselves a roadmap. And in the roadmap, I was able to figure out where my sides and angles were. Right? And then after that, you can kind of plug them into a proof. The thing that people miss the most is this like middle chunk right here. Okay, a lot of people would miss this third step. Okay, make sure that everything jumps logically, right? I started with perpendicular, so I have to then say that I have right angles, and then after that, you can say that the angles are congruent, right? So it has to be like very connected. It has to follow a logical thought pattern, and you can't like leave anything out, basically. Okay. All right, so let's look at another one. Okay, so in this one, I have PQ is congruent to QR, congruent to RS, congruent to SP. Okay, so that means this. I have all four sides here that are marked as congruent. Okay, all right, super awesome. So just right there, I have side and side, and then I just need a third side. Well, I have this shared side, right? PR is congruent to itself. So now I have side, side, side. Okay, so that's kind of my roadmap. I'm going to start with saying that we have these sides that are marked in blue as congruent. Okay, and then this side that is congruent to itself. And then I have two congruent triangles with S, S, S. Okay. All right, so let's go ahead and kind of fill this in. Now, the one thing we want to be careful about is in writing our statements, we have to make sure that we write the correct statements and say the correct sides are congruent to each other. Okay, so for example, I don't want to write PQ is congruent to QR. It's true, but those two sides are in the same triangle. See it right here? Same triangle. So that doesn't really help me very much, right? So I need to make sure that my congruence statements are matching up sides in different triangles. Okay, so the sides that I actually want to match up are PQ and RS, right? Because those go together, right? And then I also want to match up QR and SP because those are the corresponding parts in the individual triangles, which you can kind of see in the way that the triangle congruence statement is written. Okay, so here, statement 1 is that PQ is congruent to RS. Okay, and my reason is that that was given to me. Okay, so that's my first side. Then I need to do the same thing with the other side that I have marked in blue. QR is congruent to SP. And again, that was given to me. Okay, then the third one is the side that I marked congruent to itself. So I said PR is congruent to itself, congruent to PR. Okay, remember whenever things are congruent to themselves, that's always the reflexive property. Okay, so now I have side, side, side. So I can now say these triangles are congruent. Triangle PQR is congruent to triangle RSP because of side, side, side congruence. All right. So we've got 2 more here, and I want you all to see if you can try these out on your own. Okay, remember, make yourself a roadmap, and I'm going to give you a hint here that you have some vertical angles in this one that will probably help you. And here you have an angle bisector. That's going to help you, as well as you have a shared side here, which is going to help you, okay? I know this diagram here looks a lot like this diagram up here, okay? But I don't want you to assume that these are right angles right here. Even though they look like right angles, we don't know that for sure. Okay, so you can't use that. You can only use what you have marked and what we know for sure. Okay, so give these 2 a try and then come back and see if you got your proof correct. See if you answered this correctly. All right, so I'll see you in just a moment. All right, folks, so give these filled in proofs a look here. So I'm going to kind of talk you through these, check and see if you had something similar to what I wrote here. Okay, so this first one was not very many steps, which was kind of nice. Everything was basically given to you. So I started with my 2 givens. Angle K is congruent to angle L, and KH is congruent to LH. So the angles here are marked in blue, and then the sides were marked in red or pink. So I had one side and one angle, and I knew I needed one more thing, either another side or another angle. And in this diagram right here, I have vertical angles that you can see in the actual diagram, right? Which is marked in green there. Okay, so whenever you see vertical angles, it's usually a good idea to go ahead and mark them. Okay, because most of the time you're going to need them. Okay, so I have angle GHK is congruent to angle JHL, and the reason I gave is because vertical angles are congruent, or you could have said like definition of vertical angles or something along those lines. Or you could have really just said they're vertical angles. Right? Either any of those would be fine. So now I have 2 angles and a side stuck in between them, which I kind of have labeled for you on the side here. So those 2 triangles are congruent by ASA. All right, so now I do want to tell you one more thing about this that may come up. So in problems like this, there may be proofs where they ask you to show the triangles are congruent and then show after that that some parts are congruent. The only reason I'm bringing this up is because there is a problem like that in the practice problems video, and I'll go over it in more detail then. But I'll add it to this last proof here so you can kind of see what I mean by that. So we can use what we learned in the last section with the corresponding parts and corresponding parts of congruent triangles, and we can use that in a proof as well. Okay. So here's the last proof. Okay. Again, they gave me a lot of information that I can use, but only one piece of the given information gave me like a side or an angle that I needed. So they told me AD was congruent to CD, which I have marked in blue there. Okay, and that was given. The other piece of given information was that BD was an angle bisector of, and it should have said angle ADC right there. So if you wrote triangle, don't worry about that. Okay, so this alone, the angle bisector, is not enough to say, oh, I have an angle right there. I have to actually write which angles are congruent because of that, right? So those angles are marked in pink up here. Angle ADB is congruent to angle CDB, right? And the reason I know that is because a bisector, an angle bisector, divides an angle into two congruent parts. And these are the congruent parts. ADB and CDB are the congruent angle parts. Okay, so there's my angle. So now I have a side and angle. And then I also have that shared side in the middle. So that's my step 4 there. BD is congruent to itself because of the reflexive property. So now I have that these two are congruent. Okay, these two triangles are congruent by SAS. Now, if, for example, this prove statement had actually said, now please show that side AB is congruent to side CB, for example. Okay, so once I know the triangles are congruent, I can say all of the parts are congruent as well, the corresponding parts. So I could say AB, side AB is congruent to side CB because they are corresponding parts in congruent triangles, right? Right here in step 5, I have congruent triangles. So I can use, remember that acronym from last week or in the last like couple of videos, the first set of videos in this section, CPCTC, which stands for corresponding parts of congruent triangles are congruent. Okay, so if you are asked to show the triangles are congruent and then break it down further to show that the parts are congruent, okay, you can do that, but you have to show that the triangles are congruent first before you can use this CPCTC step. Once you know the triangles are congruent, then you can say all of the corresponding angles are congruent and all of the corresponding sides are congruent. All right, so that is it for this examples video. I have a couple more proofs for you in the practice problems video. So if you still need a little bit more help with proofs and kind of breaking this apart, then join me in the practice problems video. I'll see y'all in the next one. Bye, everybody.